the nice thing about function notation is just it's just another way of expressing the y value or the dependent variable, but it's telling you for sure, this is a function and this is what you're plugging in for the independent variable. So if they say f of x equals mx plus b, or f of x equals 5x plus 7. And it doesn't have to be f. You can name it anything. You could name it g of x or h of x or star of x. It's just a name for a function. And we can name a bunch of different functions that way, rather than just having a bunch of y value, y equals this, y equals that, y equals this. We can say f of x equals this and g of x equals this. So we can distinguish between functions by using function notation. So today what we're going to do is review. This is pretty quick again. We're not spending a whole lot of time on this, but we do have some time today. We're going to review lines from Maricheck 3.1 through 3.3 using a Kahoot. If you participate in the Kahoot, I will give you more credit on your homework. So just keep that in mind. If you are participating, you will get extra credit on your homework. And then we're going to work through these problems. I'm going to put y'all in groups. And what I'm going to do is, in each group, I'm going to assign a couple of problems so that when we come back into the classroom, you'll be responsible for explaining those problems to the rest of the class. Okay, so before we get into the homework or the classwork, let's go ahead and do the Kahoot. Okay, so if you will join this Kahoot, there's the pen, and again, if you are participating, I will give you extra credit on your homework.
I was gonna say the guy that did a lot of the guy that actually, I think he developed set theory was Cantor, and he's kind of crazy.
Oh yeah.
Yeah, a lot of old mathematicians were also like philosophers. There's quite a large overlap, and yeah, that was one of them because he developed set theory, and it's used both in. If you take like symbolic logic, like that's pretty much all they do in there. I went in that class and like. Literally, you don't do anything different than what you do in math classes. It's just different symbols, but it's the same concepts.
Yeah, it can get pretty crazy though.
Yeah, he was definitely in his own little world for some time.
A lot of them were.
Yeah. Did anybody have problems seeing the 3.5 notes video? It should be up on YouTube.
It was fine. I saw it.
The only thing is it wasn't in the playlist. I had to go to your like full video list to find it.
Maybe they didn't put it on the playlist. We can fix that too.
Okay. All right, so let's go ahead and get started. And these don't feel bad if I did not put a whole lot of time on these, so answer as quickly as you can, and then If you don't have time to finish to do it, hopefully you will, but if not, it doesn't mean you're not smart. It just means that I didn't put a whole lot of time on these because I didn't want to spend all period doing them. Okay.
Let me turn.
Choose the point that is not a solution to this equation. Okay, so if we look at this, y equals 6x plus 9. Okay, so if we look at the points that were given here, 0, 9, 9, 0, 1, 15, and negative 1, 3. Okay, so this one, 0, 9, that would be 9. Does that equal to 6 times 0 plus 9? So it does. Then this one here, 0, does that equal to 6 times 9 plus 9? And that does not, right? 0 does not equal to 63. So that would be the one. All the rest of them will work. What was it? 1 and 15. Does 15 equal to 6 times 1 plus 9? It does. Does 3 equal 6 times negative 1 plus 9? It does. So remember that what it means for a point to solve an equation is that means that if you plug it in, it gives you a true answer. Choose the point that is not on the graph of this line. Which one is not on the graph? Okay, so I know that there was not a whole lot of time on this one, so don't worry about it if you did not get it. But let's look at this. So the way that the question's worded is different, but it really means the same thing. This first question says choose the one that isn't a solution. And then I said, on this one, I said, choose the one that isn't on the line. That means the same thing. Like if it's a solution to a linear equation, that means it lies on the line. So again, I'm going to plug 0 in. So I'm going to say 3 times 0 plus 2 times 4. Does that equal to 12? And right off the bat, I found the one that didn't work, because that does not equal to 12. The rest of these will work, like 3 times 4 plus 2 times 0, that does equal to 12. And 0, 6 would work, and 2, 3 would work. So if a point lies on the line, that means it also is a solution to the equation.
Okay, so I put that video on the playlist, so the lesson should be on the playlist now. I uploaded the video, but I didn't put it to my playlist, so it was on my account, but not on the playlist.
Find the slope. Good job. So here, you can either do it using the graph, which would mean you would, if you go from this point to this point, you would rise 2 and run 4, which reduces to 1/2, or you could do 0 minus -1 divided by 0 minus -2. You could use the slope formula, and you would also get 1/2. Find the slope of the line between 2 points. And then make sure you write this down, because you'll need it for the next couple of questions. Whatever slope you get, you will be using it again. So make sure that you hang on to it. Okay, so the points are -2, 6 and 0, 3. So we'd say y2 minus y1, 3 minus 6, which is -3, divided by 0 minus -2, which would be 2. So the slope would be -3/2. Watch your signs on those. Be careful with those signs. And also make sure the difference of the y is on the top and the difference in the x is on the bottom. Okay, hang on to that slope. Slope is -3/2. because you're going to need it for this next problem. Right, the equation of the line that passes through these 2 points. So we know the slope of the line that passes through these 2 points. So you should be able to easily write the equation of this line because we also have the y-intercept. Good, good job. So we know that the slope is -3/2 because we found that in the previous problem. And then we know that the y-intercept is 3, is 0, 3, means it passes through the y-axis at 3. So the equation would be y equals -3/2 x plus 3. Find the equation of the line that passes through 0, 5 and is perpendicular to a line that passes through same points. So using this slope, you want the perpendicular line that passes through 0, 5. So again, we know the slope and we know the y-intercept. Okay, most of y'all got that, that's great. So we know that the slope of, so we know the slope of the line that passes through these 2 points is -3/2. So the slope of the perpendicular has to be both opposite sign and flipped. So the new slope is 3/2. And the y-intercept of our new line is 0, 5. So the equation would be y equals 3/2 x plus 5. So when they tell you these kinds of questions, a lot of times people get all discombobulated. Once you use that slope from this line, you can just throw that line away. The only reason that you needed that was for the slope. And then it doesn't have any more meaning to the problem. And then you just go and go with the information that you need to write the correct equation. Which is an equation of a horizontal line that passes through 5, 3. Good. Okay, so remember that the equation of a horizontal line is always y equals to a constant. The only y value here is the number 3. So it would be y equals to 3. A is equal to 1,370 minus 0.26c, models the number of adults in millions who smoked cigars in the year C. How many adults smoked cigars in 2018? Good. So all you had to do was take the number 2018 and plug that in for C and simplify that. And you got 80, I got 845.32, which is close to 845 million. Same equation, interpret the slope. Kind of all over the place here. So if you look at this, remember that the slope is always the number in front of the independent variable. So the slope, even though it's not written in slope-intercept form, it's always going to be the number in front of the variable when it's solved for the dependent variable. So this does mean that the slope is negative 0.26, and it means cigar smokers declined by $26 million in a given year. So like when we plugged in the year 2018, that was saying in 2018, we're going to take that negative 0.26 times the 2018, subtract it from 1370, And the because it's negative, every successive year, the number of, I just totally made this up anyway. I have no idea about anything about cigar smokers, but according to my imagination, every year the number of cigar smokers is going down by that ratio. Same equation. And now I want you to interpret, what does the a-intercept mean? Remember, the a-intercept is like the y-intercept. What is that? Interpret it, and what does it mean? As I noticed on the homework the other night, a lot of y'all were able to tell me what the slope and the y-intercept were, but a lot of you did not interpret what it actually meant. Okay, so good. Most of y'all did get this. So the reason that the triangle red one is wrong is because that's an x-intercept, not a y-intercept. So watch that. So the y-intercept or the a-intercept is 0, 1370. And that means at year 0, if you plug 0 in for the C, which is the year, then you would get 1,370 million smokers. Yay, Hunter. So you get an extra point. Chelsea gets an extra 2 points. And Timothy gets an extra 3 points. So everyone that played gets 5 points. And then the top 3 get a few extra points. Okay, so let's go ahead and look at what we're doing today. Okay, so what I'm going to do is put y'all in groups, and then I'm going to jump in and tell you which problems that I want you to be able to share with the class when we come back together. There's only 10 problems, so this should not take long, but I want you to focus on the ones, I want you to do them all, but I want you to focus on the ones that I tell you. So how many students? Matt, I can't see how many students we actually have. How do you see that? Oh, I can't hear you. Sorry.
There's 15 participants minus us. That would be 13.
13. Okay, so let's split them into 4. Will you do that? Can you do it? Do I have to do it?
I think you have to do it.
Okay, let me do it. Okay, so let's see here. Da, 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 da. Okay, here we go. Okay, so I'm going to put y'all into 4 groups, and then I'll jump in and tell you what problem.
Okay. All right. So what problems are we doing?
I have no clue.
Oh.
She said she's gonna put us in groups and then tell us.
Oh. Okay.
I'm waiting on her to come around.
8, 7.
Now I have breakout rooms option.
Okay.
Underground.
Hey, you guys.
Hi.
So I was talking to the other group, and I gave them 287, 291, and 297, and I told them, like, on number 287, you can abbreviate those names and birthdays, or you could even say, like, in the one column you can say, you know, A, B, C, D, E, F, G. You can rename them if you want to, because sometimes it gets your hand will cramp if you try to write all that stuff out. So you can abbreviate, just make sure it's clear to me. So what I would like your group to do, and then decide who will present it, is 301. And again, you do not have to write that, like, you make Raoul be Paul, and then you could say JRDEP, and then you can abbreviate the emails as well. You don't have to write all those out when you're listing the ordered pairs. So 301 and 309. If y'all will do 301 and 309, that would be awesome.
All right, that's all.
Yeah, well, I want you to do all of them, but I want you to be able to present 301 and 309 to the class.
All right, sounds
All right.
good.
Thanks.
Mhm.
Do y'all have those problems?
Yes.
Yeah, I see him right here.
All right, cool. Yeesh. Uh, Ooh. So is it a function?
No, it's not a function.
Why? Who breaks it?
Jenny.
Yeah, Jenny and Roe, huh?
Mm-hmm.
Yeah, that's it. You got one input giving you multiple outputs. The main is all the names. That's pretty straightforward, huh?
Mhm.
Hopefully, I hope it's straightforward. The domain is what?
The domain is the name.
Yeah, and the range is the emails. That's it. The other one is you're just plugging stuff in, huh?
Mm-hmm.
Evaluating the function.
Yeah.
$335. Is every relation a function? Is every function a relation?
I'm gonna think no on that.
So there's two different questions. Is every relation a function? No, not every relation is a function. Is every function a relation? That one should be yes, right?
Yeah.
Yeah, because a function is a type of relation. It's just a really specific type of relation. It's like a set subset sort of thing, right? The
Yeah.
larger set is the relation. The function has very specific things it means, and it's this smaller set. Yeah. I'm gonna bounce it around, I think. Unless y'all got questions, what else? 329. Just making you do part A. Cheap. What was this? Plugging stuff in. Most of it's just plugging stuff in, huh? Like 319, that one might be a little challenging. With the h squared and the x plus 2. I feel like it's one of the more challenging ones on here.
So we also do 311, 319 is what you're saying?
So you're supposed to be like kind of working through all of them, the ones that she said that for y'all to have polished and like be able to present
Oh,
are
okay.
like 301 and 309. But like,
Oh, okay.
yeah, y'all should be working through all of them. I mean, you're gonna have to submit all of them for homework. So,
Yeah.
so it's like kind of to your advantage to start working through them in class, you know. Yes, 287 is just a lot of writing. Uh, 287, 291 was the next one. Can you find like a domain and a range from a graph? I guess is what that's doing, right? Uh, 297s if you can find it from an ordered pair. Where's she at? I think I'm bouncing to another room unless y'all got questions.
I think we're good.
All right. You go here.
Measure and weeks.
What are y'all doing?
We just finished 327. We've been assigned 327, 329, and 335. Right now we're working on 329. Problem A. Very last page.
Okay. (329A) determine the independent and dependent variable.
Yeah, just what's more is writing. So,
Is the what?
we just have to write out the equation, right? So like, what does 20t represent? What does 85 represent?
So there are two variables that I see there, right? There's the n of t and then there's the t.
Right.
And so they want to know which one's independent and which one's dependent.
Would 20t be dependent?
I thought it was independent.
Or sorry, the t?
The t is the time, right? And so the time you said was what? Independent? Is that what you said?
That's what I said.
Okay. Yeah, time will always be independent, right?
Okay. Yeah, I just wanted to make sure.
Yep. Or almost
So,
always. Maybe I shouldn't say always. There's probably some weird case that they could throw out. But
depends
like
on how they write
in
the
our
equation.
class, like if we see time, I'm pretty sure it'll always be the independent. Because everything depends upon time, not the other way around, right?
Yeah.
Yeah. And so if that's your independent. In general, like your x is your independent, right? That's the way we typically kind of structure things. Is like
And
your
so
x or domain. What was that?
I'm sorry. I was that a dependent. I got mixed up. There's no variable in 85, so that doesn't really count as a variable. So n would really just be the number of unwatched shows. I feel like I'm missing something in there. Like it's supposed to be like a certain word. You know what I mean? Because right now I just have.
It's just your t or your time is your independent, and your n or the number of unwatched shows is your dependent, right? That's correct.
Oh, yeah, I feel like that's really.
Yeah, that's it. That's all they're asking.
Wow.
Yeah, it's not asking very much on that one. It's just like,
Okay.
like, can you
I'm
determine
just
which
curious
variable is
to,
which? I feel like they should have made you do that whole one and find in for and explain what the heck that means.
Uh-huh.
Yeah.
No, it's okay. I'm just kidding.
Okay, fine.
That's what I would have made you do.
So y'all feeling good about this as far
Yeah,
as
it's making sense.
okay, and you'll feel like y'all be able to explain it to the class?
Yeah, absolutely.
Perfect.
Okay, 335 is every relation a function, is every function a relation.
Real quick, Chelsea and Aurora, for problem B, I got 165. I'm sorry, n t equals 165.
Ooh, let me try that real quick.
Good God. Chelsea and Aurora?
Yeah, plus 85. You said you got 165?
Yeah, 165.
Okay, I got the same.
Awesome. Aurora, I want to know, is everything all right? We haven't heard much from you in the chat.
Not really, but I'm trying to follow along.
Okay. Listen, if you have any questions, just go ahead and ask. If not, whatever it is. Okay. 335. Is every relation a function? Is every function a relation? It's kind of a yes and no.
I think every function is a relation, but not every relation is a function.
Well,
Wait.
so for a function, here, hang on.
Yeah, that's it. She
I
said it right.
remember this is in the vocab. This is in the vocab. Give me a second. Right. So a function is just where an x is paired with a y. But I'm from far back. I do remember there are some functions that have an x and an x, which doesn't make any sense. But in order for a relation to work, every single function has to have an x and y value. But there are some relations that are, there are some functions that are mixed up that don't really go in an order. Like there would be like a positive x, a negative y, and then there'd be a positive y and a positive x next to it. You know, but it'd be mixed up. The ordered pairs would be mixed up, kind of not really setting it all in a straight line, if that makes sense.
Yeah.
So is every relation a function? Is that no? However, every function it can be a relation because really a relation is just an ordered pair.
Yeah, a relation is any sort of thing, right? That relates one
Right.
set to another. Yeah, that's it.
Okay, awesome.
I'm thinking like this is the picture I kind of have in my head too. Like one's kind of a subset of the other, right? Like I don't know if I could see that, but a relation,
Yeah.
a relation's anything out there that relates any two things, right? A function is more specific, right? It's like any input I have has to give you a specific output. It can't give you multiple outputs, right? So for any x, I can't have multiple y's. It has to give me one thing when I plug it in. That's what a function is. And like, I hope that makes a little bit of sense, like why we kind of talk about.
It does give a clear idea of what to look for, you know, and should the question ever come up again.
Yeah, so you look for that repeating x with a different y is what you look for when you like test the function, right?
Right.
Yeah. And I hope it like makes a little sense because when we want something to function, right, we want to be able to plug something in and get one result out of it. If we're plugging something in and we're getting multiple results, that thing's not really functioning, right? I don't know.
Yeah.
Not really conclusive.
Yeah, you're like, I want to be able to plug one thing in and get one thing out. You know, it's like, okay.
It's like it's like you can't have like two y-intercepts.
It's like if you had a Coke machine and you hit the Coke button and it gave you like either like a Coke or a Dr. Pepper or a Pepsi or something, you know, it's like you want it to give you
one
one
thing.
thing.
Mean one thing.
Yeah.
And if it didn't, you would say the machine's not functioning. That's a good analogy. I never thought about it that way. But yeah, I mean, these things are principles that we can apply to real life, and we can apply it to everything out there. I don't know.
I can definitely see a couple of these coming up later in life.
Yeah.
So we just we already did 3 of them. Do we just?
Yeah, I guess do all of them is what y'all should really do. Because I mean, you're gonna have to do all of them anyway, like in submit them for homework. But I would really look at 319. That one looks like an interesting one. It looks like one of the more difficult ones.
G of x minus oh yeah.
Yeah.
Wait the function.
Up for the challenge.
I'm gonna scatter myself and make sure everyone else has something going.
All right.
What have I not been? I don't think I went to 1 yet. I was in their guys group for a second. Okay.
So g of x equals 3 minus x. Okay.
And I'm fixing to pull everybody back in class. Are y'all ready?
Yeah,
I'm ready.
Okay, great.
Okay.
Real quick, Chelsea, do you want to do all of them, or do you want me just to explain it all?
Okay, are we all back?
Yeah, everyone's back.
Okay, perfect. Okay. All right then, group 1, would you tell me what you did on 287?
So I did what you said and shorthanded everything to a number and a letter.
Okay, so what number did you attach to everything?
The name side is 1 through 10.
Okay,
And then the birthday side is, let's see, where's my thing? A through H.
okay. Okay, and so you could do shorthand, like y'all could have done something different, but that's fine with me if you do that. Okay, so what are the ordered pairs?
I have 1A, 2C, 3A, 4E, 5B, 6D, 7H, 8G, 9G, and 10F.
Okay, great. So just, I know this was not part of the question, but would this be a function?
Yes.
Yes, why is that?
Each one on the left only comes out to a single Y.
Right, you don't have any of your X values repeating, right? Yes, good, good, good. All right, so what's the domain? You can just go 1, comma.
Yeah.
2. Okay, and then the range?
A through H.
Yeah. Okay. Okay, so 291, list the ordered pairs. Someone else in that group? Someone else do? Hunter, do you want to do it again since no one else seems like they're.
I can do it.
Okay,
I
please.
was
I would love it. Thank you. Thank you.
I was trying to unmute myself and that was not
Okay.
working.
I have that problem too, so go ahead.
For the ordered pairs, I got 0, -3. 4, -3. -2, -1. 4, -1. 2, 3. And -3, 4.
And the domain?
For the domain, I got -3, -2, 0, 2, and 4.
Great. And the range?
For the range, I got -3, -1, 2.
Where's the 2? Did I miss it somewhere? Is there a 2?
Nope, nope.
That's okay. Sometimes I'm like, okay, where's the 2? Okay, so -3, -1, and then
And
what?
then -4.
4 and 3, right? Also
Yeah.
3. Yeah.
That was where I messed
Okay.
up.
Okay, so for the domain, it's the X values. For the range, it's Y values. Then question, is this a function?
Yes.
Okay, so look, what happens here is, look, the 4 is paired with both -1 and the -3.
Oh
So
yeah, that was what I was going to ask about.
Yeah. So anytime you have x values that are paired with more than one y value, it's not a function.
Okay.
Okay, also, we'll also be talking about what's called the vertical line test. And y'all probably remember that, and Matt will be talking about that on Monday. But if you can draw a vertical line and you touch more than 2 points, it's not a function either. So the y values can repeat all day long. It's the x values that we're worried about. Because that's what's the beauty of a function. It's like if I give you an x, then you can bet your life and your grandmother's life and put your hand on the Bible and swear that you know what the y is going to be. But if it's not a function, you can't do that. All right.
I kind of thought of it like an analogy, like a Coke machine is like a good way to think about a function. Like if I push a button, if I have one input, I want exactly one output out of that thing. Like I want to, if I hit the Coke button, I want a Coke to come out. I don't want to hit a Coke button and maybe it be a Dr. Pepper, an orange Fanta or something. I don't know. Right.
Right.
I want exactly one thing out of there. And if it didn't, you would say the machine doesn't function, right?
Right.
Yeah.
And that has happened before. I mean, I know sometimes I punch the Diet Coke and I'll get a Coke and I'm like, dadgummit, this machine isn't working. So yeah, but if it's functioning correctly, you punch the button and you know what you're going to get. All right, so who's next in that group to list the ordered pairs? Who else is in that group? Okay, well, one of y'all that I've already done it, would you do it again?
Yeah.
Okay. So, so all they want here is the domain, the range, and is it a function or not a function?
Mhm.
Okay, so tell me what the domain is.
Domain is, let me make sure I got the right one. Okay. -3, -2, -1, 0, 1, 2, and 3.
Okay, great. And the range?
0, 1, 8, 27.
Okay. Yep. Is it a function?
Yes.
Yes. Because why?
Every x has its own y value.
And I always like to say it's the x's don't repeat, but one of the co-teachers I used to teach us, well, that's not really true because I could say 5, 10, and then further on down the line say 5, 10 again, and then the x's repeat, but I'm not going to do that to you. So basically, if the x's are not duplicated,
Right.
it's not a function. Okay, so now we're to group 2. Can someone list the ordered pairs here from group 2?
Yeah. So I did J with JK
Okay.
and J with J. And then I did Randy with Randy. And then I did D with D. Then I did E with ES. Then I did Raoul with RH.
Okay.
Then I
Okay.
did Raoul, well, just do R with R.
Okay.
Raoul with Raoul.
Okay. With the RA and R. Okay, so see, we got 2 RAs. Now I'm confused. So we got RH and RA. Okay, gotcha. RH and RA. Okay, so the domain would be, and just to make this quick, the domain is going to be these guys, right? I'm just going to say
Yeah.
J, R, D, E, and I call Raoul Paul, but whatever. And then the range will be these guys are going to be the range. Okay, so is it a function?
Yes, it is Wait, no, my bad.
Oh,
It was
right.
the
And
function.
so when you have a chart like this, if you've got more than one arrow coming off of an X or the independent variable, then it's no, right? Because Jenny is paired with J Kim and Jenny AOL, and Paul is paired with this guy and this guy. So it's not a function because Jenny is paired with 2 email addresses.
I know we use these diagrams a little bit, but I'm not sure like we even use them like too much past this lesson.
Yeah, I
We
know.
use like ordered pairs a lot more, and we use things like domain and range and things of that
Right.
nature a lot more.
Yes, and that's why it's always good to list the ordered pairs if you're ever given something like this, because then you can see, well, this was kind of hard to see because we've got so many J's and anyway, but you can usually see what's going on.
But those do give them a good visual like representation of we have a domain here, we have a range here, we have these 2 sets, and the relation is the arrow in between, right?
Right. Right. This is how they're associated with each other. All right, so now we're on 309, still group 2.
Mm-hmm.
Okay, so what's f of 2?
So for f of 2, I did -4 times 2 plus 2. Then I got -8 plus 2. Then I added them together, which got me -6.
Great. And then f of -1?
F of -1, -4 times -1 plus 2. I got 4 plus 2. Add them up, you get 6.
Yep. And f of a?
F of a, 4 times a plus 2, 4a plus 2.
-4a plus 2, right?
Yeah.
Yeah. So you're just taking that a and sticking it in place of the x. Great. Thank you. All right, group 3, number 311. I know y'all had this one because I was in your group for a while.
Okay, so we put 2 for the x.
Okay.
2 squared minus 2 plus 3, which is going to be 4 minus 2 plus 3, and then 2 plus 3 equals 5.
Perfect. Okay. F of -1.
-1 for x.
Okay. Plug in -1 everywhere you have an x. And what would that give you?
5. Oh,
So
you get negative
1 plus 1 plus 3. Yep. And then f of a.
and then you just plug in a squared minus
That's
4.
right. Perfect. Great. And then what about 319?
So I didn't get to 319.
Okay. Did anyone do 319 that wants to walk me through it?
No, I didn't do it either because it was taking me a long time to get into the breakout room.
Okay, I understand, I know. Okay, so let's just go through this. So here, g of h squared just means that everywhere you have an x, you're going to put in an h squared. So that would be 3 minus h squared. G of x plus 2 means that everywhere you have an x, you're going to plug in an x plus 2. So you would distribute that negative, which is an implied -1, and that would give us 3 minus x minus 2. And 3 minus 2 would be 1 minus x. And then g of x plus g of 2. G of x is just 3 minus x. And g of 2 is 3 minus 2, which is 1. So g of x plus g of 2 would be 3 minus x plus 1, which would be 4 minus x. Okay, 327, group 4. Someone do number 327 for me, please.
Okay, so we just plugged in the 2 for the x.
Yep.
So just 2 plus 2 over 2 minus 1, which would equal to 4 over 1 simplified to 4.
Yep, perfect. Great. And then what about 329? Just all they wanted you to do here is determine the independent and the dependent variable for this function.
All right, so the independent variable is obviously going to be 20t because it represents time.
Just the t, right?
Right. And the dependent variable, which is n over t, represents the number of TV shows watched.
Right. Okay, so you're like, if you want to know, you plug numbers in for t, and that will give you your n of t. So n of t is, or n is the dependent.
Real quick, Ms. Watson, do we have to, can we just like write it out like that? Or do we have to like put in, like interpret in a sentence?
Sometimes they'll ask you to interpret it, but in this case, it just said determine the independent and the dependent variable.
Oh, okay.
So, yeah, I know. Yeah. Okay, so finally, is every relation a function? And is every function a relation?
Well, no, not every relation is a function, and yes, every function in a way is a relation.
Right. So not every function is a relation. I mean, not every relation. Can you give me an example of a relation that is not a function?
Sure. Look at 301.
Okay, right. So like if you go back to 301, right here, that's not right. This is a relation, but it's not a function. So if you have like this 1, 2, 3, 4,
repeating variable.
Right. If the x's repeat, it's not a function. This is a relation, but it's not a function. But is every function a relation? Every function is a relation. Because every function is a set of ordered pairs, but it's just a specific set where the x's don't repeat.
Yeah.
Or every x is paired with exactly one y.
I think of it kind of like in a like a set or a subset, like a Venn diagram or something. I don't know. You can see that. Yeah, like a relation, and then a function is a very specific type of relation. I don't know if that'll help them or not.
Yeah, functions are inside the set of relations. So, yeah, and I really like the Venn diagram, I mean the vending machine analogy for a function. I also like we'll be discussing many different kinds of functions. Like for example, if I gave you a social security number, could you tell me if you had access to everybody's information, and if I gave you a specific social security number, could you give me the person that social security number is attached to, the specific person? Yes or no?
Yes.
Yeah, right. That's why we all have social security numbers. Everyone has their own individual social security number. And if I give you a social security number, then you can tell me that belongs to Andrew James Smith or whoever. You can tell me exactly who it belongs to. But if I give you a name like Mary, can you tell me what the social security number that goes with Mary is?
No.
No, because there's, how many Marys are there in this country? You know, so So if I give you a value and you can for sure tell me the value that's associated with it or the person or the thing, then that's a function. If I give you a value and you don't know exactly what comes with it, then it's not a function. We actually finished in front of time today. Isn't that amazing? If anyone has any questions, I'll be glad to field them. I'll be here for office hours unless nobody sticks around. But
I know I mentioned it in the video, but another common mistake people make with like that function notation is they think it's multiplication. The input's multiplication, but
yeah.
So like if f of 2 equals -6, I think was what 309 was, something like that. Where is that? 9, yeah. And so they'll see like f of 2 equals -6, and they'll try to divide that thing by 2 for some reason.
Oh, yeah.
Yeah, that's not multiplication there. Don't do that.
It's just the f and the g or whatever. It's just the name of a function. It's naming it and telling you what to put in it at the same time, which is what makes it such nice notation.
I know we use parentheses for everything, and that's part of the problem there. I think. It's an input. It's not multiplication, is what that means.
And there's several ambiguous things in mathematics, like, and we'll learn this in a, like a negative exponent can mean mean different things. So you have to know the context of what you're working with.
The other thing that I didn't even realize is like, is it an interval or is it a point in space?
Yeah.
Space, yeah.
Oh, right. All the time. Yeah. It's like, that's another ambiguity. It's like,
are we going from 1 to 3, or is the x 1 and the y 3? Like,
yeah.
I don't know.
I know. It's like, and the worst notation to me is log notation. It's like, who came up with this convoluted mess? But anyway, that's
funny because log notation is very prolific in programming.
Yes, it is. And if you understand it, it's no big deal. It's just like, but it's I can think of a million different ways that I think would be better ways to
Do not understand it, so
yeah.
I got to figure that out.
Well, you will after this class.
Yeah, logs are more towards the end. I know that.
Yeah.
Do we still teach circles in here?
No.
Or did they kick those out? They kicked the circles out.
They kicked out those.
Yeah.
And they kicked out the conic sections. I think those are out too. All the conic sections. Maybe not. Oh, except
we do parabolas. Yeah.
Yeah. Yeah, I think anything that's not a function kind of got kicked out. Anyway. All right, guys. Well, we'll see you tomorrow. Look over your tests and make sure you, if you have questions about them, that'll be a good time to ask.
Yeah, I would go through your test and everything that you got wrong, go back through and correct it. Make sure you know what you did wrong. Make sure you have the correction. And if you still like have no clue after looking through it, we got tomorrow to talk about it.
Right. Yeah. And so we'll go over that and then probably do some quick review over what we've been talking about for the week.
Yeah. And 3.6 should be up. And it should be in the playlist. Yeah, if you ever don't see a video in the playlist, I guess go ahead and double check, make sure it's in my account, because I will have the videos up in time. And if I don't, then something went wrong, you know. But I fully well intend to have the videos up before y'all need them. Any questions over anything?
See, I kind of lost track on 319C, the g of x plus g of 2.
Uh-huh.
So I was just figuring out how I needed to plug that one in again.
Okay, so 319.
With parentheses.
Okay, g of x plus 2.
Yeah, the g of x plus g of 2.
That was, where was that one? G of x plus, g of x plus g.
It's on 319, right there.
Oh, right here. Okay, got it. Okay, so g of x, okay, so this one, let's see if I can make this more clear. This one was this was A. This was B. And then this is C, the g of x plus g of 2.
Okay.
So for g of x, you first found g of x by just plugging in x. Just so it basically, and then g of 2, you just plug in 2.
Okay.
And then you just combine them.
There's also like kind of an overarching point I think they're trying to make here, and like the distribution doesn't work because this is not multiplication, right? Again. Yeah.
And it doesn't work with any functions, which is always, it cracks me up when someone tries to distribute a log or a exponent, or it's like, no, that doesn't work.
Okay, great. I think I got it. Thank you. Y'all have a good day.
You too.
Got 3 people that fell asleep.
Well, let's